Okay, for this problem we need know for FA and FB, knowing about from the this angle is for 20 grades and this angle is 0, and we need apply the sine law. Okay, in this triangle we divided in two parts. This part is equal to 950 newtons, and this angle it's a right angle. This part is of 19 grades, and this part is of 19 grades. We need uh, we need we need have a subtraction. It's equal to this angle. This angle is equal to 0. It's equal to 19 grades minus 20 grades. This is equal to 17. And the next part is calculate FB and FA. For calculate this, we need 19, 950 it's newtons for sine of sine of 20, and this is equal to 324 newtons, and this is the first answer of FB. And for FA we need 950 cos of 20 for this angle, and this is equal to 892 newtons, and this is the second answer of FA. Okay, the last problem says determine the projected component of the force FAB equal to 516 newtons. This part acting along cable AC. Important, the cable A. Important again, the cable AC. What is the cable AC? Okay, this is the letter A. This is the letter C. In this cable, in this is the letter A, the letter C in this cable. Okay. We can see this picture in 3 axes. The axis X, the axis Y, and the axis Z. Okay. We have three legs for side. For example, in the letter B we have 1.5, 0, and 1, because in the letter B we have 1.1, and the magnitude in the other side is equal to 0, because it's for example an x variable. We have the letter AC 030, the letter is the letter A, and the letter C 1.5, 0, and 3. The next part is calculate the unit vectors AB and AC. But what is the unit vector? Remember, the unit vectors, in this case AB and AC, it's a unit vector is one that has a model 1. Important, remember. We have the first part, but in one letter, the other part in other letter, in this case the letter I, the letter J, and the letter K, but we need calculate the square of this, because it's to elevate to 2 of to square, and we need use the square for eliminate these 2, and the answer of this is 3 divided in 7 for I, minus 6 divided in 7 for J, and 2 divided in 7 for K. It's the same case for the vectors AC. Okay, the next part of this, it's the magnitude projected for the component FAB, and that is equal to 516. That is the force in newtons, replaced by the unitary vector AB. Here, for example, the unitary vector AC minus. Okay, minus is multiplying by the force in newtons, and the answer is 214 for I, 418 for J, and 116 for K. But it's the force in newtons. Important. It's the force of the vector FAB. The next part is the magnitude of the vectors. How calculate the magnitude? It's simple. It's a multiplication of the force of the vector in newtons, multiplying by the answer of the other vectors. In this case, we have 214, 418, and 116. This is the answer of the previous, multiplying back the unitary vectors, the unitary vector AC. That this is the answer, multiplying, and the answers of this multiplying is 346.16 newtons. Important, sorry, newtons, and this is the answer. Okay, the next problem said if the resultant force acting on the bracket is to be directed along the positive x-axis, and the magnitude of F1 is required to be a minimum. Important, a minimum. Determine the magnitudes of the resultant force. This is the first part, the resultant force, and F1. F1 is this part in this picture, but in this picture we have the magnitude of F3. It's equal to 216, and F2 it's equal to 300, but we have two triangles. That signifies that we need to apply the cos and the sine law. This part is the 5, 4, 3, 12 by 5, and 13. Okay, we can see this picture in this picture of vectors. We have the same angles, but in the opposite in the other side. That said, that the angle of F1 in the x-axis, it's important. We have two axes, the x and the y axis. F1 or y, this is part. F1 or x, this is part. F2 it's equal to 300. That signifies that F2 is this part in the x-axis. F2 is this part in the y-axis. That is the same, and that is the same because are right angles. And F3 in the x-axis, and F3 in the y-axis. F3 is equal to 216. We can see this, or we can write this, and for components of F1, F2, F3, and Fr can be write as in the cos law. F1 it's equal to cos law because F1, but all this part we work in the x-axis. F2 in the x-axis is equal to 300 multiplying by 4 divided in 5. But what? Because we need work in the cos law, 4 and 5. In the calculate, this is equal to 300 multiplying in 4 divided in 5. And this is equal to 214. This is the first magnitude of the F2 in the x-axis, and this is the same for F3. We have 5 and 13 in the other side, but is 216 of the magnitude, and FRX is equal to FR. Okay, in the other axis we need working in the while, and don't need the cos, we need the sim. This is equal to 300, this magnitude, multiplying in 3 divided in 5. In the calculate, 300 multiplying by 3 divided in 5. And this is equal to 118. This part, it's equal for F3, but important in the y-axis, and FR in the y-axis it's equal to 0. The next part, it's a summatory. We need summatory of the force of the components along the x and the y-axis. We have the y-axis, and we have 118 and 214 for the y-axis. This is equal to this part in the y-axis. In sim, important because it's the y-axis, we need work in the sim, and this is equal to 420 divided in sim because it's F1, and the other part is the summatory in the x-axis, but in the positive in the two cases. FR is equal to the summatory. FR is equal to F1 cos of 0. But what this is? Okay, in these angles, we have right angles. This is equal to 19. And this part is 214 minus 100. And this 100 is addition. In this part is a subtraction for working in this x. And the answers. Okay, we need substituting the results into equation, and the first answer is of F1. It's equal to 420 and 114. But important, the minimum it's equal to sim of this angle, it's equal to 1, but 1 for what is the reason for the number 1? Okay, for the sim of 19, the right angle, it's equal to 1. Important. And this is all. This is the answers.